Alright, let's do some friction type energy, thermal energy type conservation of energy problems with problem 44 in chapter 8. So we start off with um, a frictioned floor. Friction, these lines mean friction. And a block on it. Block of mass m with a force pulling it that way. And the coefficient of kinetic friction as it slides is mu k. So the force is 35 newtons. The mass of the block is 4 kilograms. The coefficient of kinetic friction is 0.6. And the distance traveled in part A anyway, I think maybe it's part B, I forget. The distance traveled is 3 meters. Alright, part A is asking how much work is done by the applied force on the block floor system when the block slides through the 3-meter displacement. So that's the work done by the force. F is that force times the displacement, and that force is 35 newtons, as you can see in the list of givens, times 3 meters, and that's 105 joules. Piece of cake. Part B. During the displacement, the thermal energy of the block increases by 40 joules. What's the increase in thermal energy of the floor? Well, as they slide against each other, there's a total amount of thermal energy that's generated. Energy that was mechanical energy lost in the system through the frictional forces. Some of it goes in the block, some of it goes into the floor. They tell us how much goes into the block, so the rest goes in the floor. So let's figure out the thermal energy, which is the work due to friction, which is the force of friction, mu times the normal force, times the distance. And the normal force is mass times gravity in this case, because it's on a flat floor with no other vertical forces interrupting anything. And then times d. So mu is 0.6, mass is 4, gravity is 9.8, and d is 3. So the total thermal energy generated as it slid across 3 meters of friction floor is 70.56 joules. And some of that goes into the block, 40 of it. The rest goes into the floor. So we'll take 40 away, 70.56 minus 40, and that's going to give us 30.56 joules that goes into the floor. So this is total, this is block, and this is floor. So that's not too bad. And part C is, what is the increase in kinetic energy of the block? Well, as we pull this, it's going to start at rest, we'll say. And the work we do with this force is some of it's going to go to thermal energy, which is going to prevent it from speeding up as much as if it was on a frictionless floor. But the rest is going to go to kinetic energy. There's no potential energy here due to a spring or gravity, so our work is going to go into just kinetic energy and thermal energy. So work due to the pull force is going to completely go into the thermal energy plus the kinetic energy. This is conservation of energy, by the way. The energy put in. This is the system. So energy put in must go to other forms of energy and not be destroyed, just disappear. So we know this value because we solved it for it in part A, 105, and that we know this value because we solved for it in part B, 70.56 plus KE. And so now we know how much KE is. We just subtract and we get 34.4 joules. And yeah, that's it. It's a neat little problem. We got one more. Cool. See ya.